The normal range for a widely accepted measure of body size, the body mass index BMI ranges from 18.5 to 25. Using the mid-range BMI score of 21.75 as the null hypothesized value for the population mean, test this hypothesis at the 0.01 level of significance. Given a random sample of 30 Weight Watcher participants who show a mean BMI equal to 22.2 and a standard deviation of 3.1. Jelly. So the first step is you have to state the hypothesis. You have to take two hypotheses. One is the null hypothesis. Second one is the alternate hypothesis. So first we'll see what is the null hypothesis. Using the mid-range BMI score of 21.75 as the null hypothesis value for the population mean. So the null hypothesized value is taken as mu equal to 21.75. Okay, so the alternate hypothesis we take as mu not equal to 21.75. So I am sure whether when you find this equal to and the not equal to, you understand it is as two-tailed. We are going to calculate the test statistics, the second step. So for this we are going to use the formula z equal to x minus mu by sigma by root n. First we will determine the values. So from the question we can take the values. So from here we can see that the mu value is 21.75. That is the population mean. So mu is equal to 21.75. And then x value. So x value means you can take it as a sample mu. So here for the sample we have the mean as 22.2. So x value is 22.2. The standard deviation is 3.1 and the number of samples, so 30 participants are there. So n is equal to 30. So now you substitute here in this formula. So 22.2 minus 21.75 divided by sigma 3.1 divided by root 30. So after calculating this we get a value of 0.79, that is the test static. Okay, so the third step is we are going to use the table and find the critical value. So here alpha is given as 0.01. So alpha is equal to 0.01. So now we are going to refer the distribution table for this. So here when you see here it is given as for two-tailed, we are going to use the alpha in bold letters. Okay, so this is two-tailed. So we are going to use this, and here at alpha is 0.01. Degree of freedom equal to 30 minus 1, that is equal to 29. So for 29 and for 0.01 the value is 2.756. So the calculated value is, now we are going to compare this calculated value versus the tabulated value. So if the calculated value is less than the tabulated value, you are going to accept the null hypothesis. Calculated value is 2.7656. So this is less than this. So we are going to accept the null hypothesis. So that is accept is equal to 21.75.